All right, folks, it's on like Donkey Kong. We're using homework examples, section 3.5. Remember, these aren't all the problems. Those are listed on Google Classroom. I'll move on. I won't show you the spreadsheet this time here. We're going to do 8, 9, and 10 of classroom exercises. Then we're going to do written exercises number 10 and number 18. So on your homework problem set, you have 2 complete proofs. Maybe 3. Did I put 3 in there? Maybe 3 complete proofs. Okay, so those spend about 5 minutes each proof. You don't need to spend a whole bunch of time on those. It's about 15 minutes, and then save the remaining 25 minutes for the rest of the problems. Now, there is a lot of reading on some of the problems, right? Number 10, there's kind of a lot of reading there, but try to limit your problems to 1 to 2 minutes each for the rest of them, and then you should be able to get done with the rest of the problems in 25 minutes, 15 minutes for proofs. That's kind of how this is envisioned here. Okay, just to show you, these are very quick problems here for your classroom exercises. It says state which congruence methods plural, because there could be more than one way you can prove triangles congruent. Anyways, can be used to prove triangles congruent. If no method applies, says none. So it's possible that some of these triangles here, some of these triangle pairs are not actually congruent to one another. We don't actually have a justification that would confirm to us that the 2 triangles are congruent. Okay, so in parts 8 through 10, you're looking to use our reasons. So you might want to remember what the reasons are. Of course, we had the postulates before. That was SSS, SAS, and ASA. Last section, this section, what we're doing here, what we're assessing here, your understanding of and your ability to do these problems are the new reasons especially. So AAS or SAA, it's fine if you call it that one, or the HL theorem, okay? So hopefully you're practicing and reminding yourselves of what those things are here. So let's go ahead and do it without further ado. What can we see here? Oh, we have a shared side here. I'm gonna mark it up. So this is number 8. What do I know? I know that I have a right triangle here, I have a right triangle here, and it shares a side in between here. So the question is, are these 2 triangles congruent? Well, do we know that? So here you're probably thinking right triangle. So maybe you're thinking HL method, hypotenuse leg, because the hypotenuses of both triangles, they're the same hypotenuse, right? They're the same side here. They're both, this is opposite the right angle, this is opposite the right angle. So that's the hypotenuse of both triangles, and it's congruent to itself through reflexive properties. So we know it's a right triangle. We know the hypotenuses are congruent, but do we know that the triangles are congruent? Do we have a leg? Do we have a leg here? So is it possible that this leg is congruent to that leg, or that this leg is congruent to this leg? Do we know that for sure? Do we know that they are? Well, they could be. They could very well could be, but we don't know for sure, right? We don't know for sure. So I'm going to X this out, right? This is not true. We don't know if they're actually true or not. So this one is going to answer with none. This one is none. We don't know whether or not those triangles are congruent, okay? Because it's possible they want to trick you, so they're drawing in a way that looks congruent here. But I'm going to show you maybe like a counterexample that's a little bit more dramatic than the way that they drew it like this here. So here we have a right angle, shares a hypotenuse, and maybe I'll draw a 45-degree angle here, about a 45-degree angle here. I can form a right triangle like this, okay, and clearly these triangles are not congruent here, right? Clearly these are not congruent here. So this might be more like 50 degrees, and this could be 40 degrees here. That would actually be here. Never mind. This could be 50 degrees, that could be 45 degrees here, and that could be 45 degrees there. Anyway, the drew kind of messed up here. So anyways, just a hypotenuse in common, and they're both right triangles, not enough to confirm that they'd have to be the same right triangles here, okay? We don't have an H method. We have an HL method here, proving triangles. Okay, so now we're talking. Here we have some right triangles right here. Right triangles. So you're thinking, is this hypotenuse leg? And yeah, this could be hypotenuse leg here. So this actually has more than one way you could do to prove that these 2 things are congruent, because here we have an ASA correspondence, because we could just say that those are both right angles. They measure 90 degrees, therefore they're equal to each other. So those angles are congruent. So this could be ASA, or, right, so this could be ASA, or it could be HL. This one could be HL too, because check it out here. Hypotenuses is congruent to one another. Hypotenusi, I think hypotenuses is right here. Hypotenuse, right? The hypotenuse, this one's the same hypotenuse as that one. And we have the legs are also congruent to one another. So this one's also HL. Okay, so these are quick problems, right? Quick problems, less than a minute each, right? Just jam through those classroom exercises here, and then you should be good to go. All right, number 10 here. Let's check this one out here. Here we have an angle. Here we have a side and a side, right? Because this is the same side here. So maybe I'll mark it up a little bit different. This side and this side, right, congruent to themselves here. So here we have AS, and then boom, we have A right here. ASA, check that out. ASA. And here, do we have ASA? Ooh, this is a tricky one here, my friends. Do we have ASA? So here, this is an ASA congruencies in terms of it matching another triangle here. ASA, is this also ASA? ASA here? Is the side included on this triangle? Okay, so let's check this one out here. This side is included between these two angles here, right? It's in between. These two angles are part of this side right here. But question, is that side included between the two angles that we would know would have to be congruent here? So this angle and this angle here. Is that side included? No, this one's not included here. So this isn't an ASA correspondence because in one triangle, right? In one triangle, the congruent angle, or sorry, the congruent side isn't included by the two congruent angles that we know in the other triangle right here. So this one here, I believe, and maybe I'll have to check the answer key to be totally sure, because sometimes I get tricked too. Let's see here. I'm gonna make justification otherwise here. Yeah, I don't think these are congruent. No, I don't think so at all, my friends here. Because it's possible, let me see if figure out how to draw this in a more dramatic way. So this one I'm gonna go with none. And maybe I can draw this in a more dramatic way. So maybe this is like this angle here. So I'm redrawing this one here. I'm trying to move this A down here. And maybe it's like this. Okay, that angle congruent to this. And then this is a lot. A bit more, not obtuse, more approaching a right angle here. So this is a really, really wide angle here. So this would also be a really, really wide angle here because these would be congruent here. So I'm going to draw this like that. And maybe, oops. And then this is a right angle here. Okay, this is a right angle. Well, this one just keeps going here. Yeah, this is it. I think I got it. Okay, so this would be a clear counterexample to this here where, hey, check it out. Let's say that this degree measurement here in the way that I've drawn this triangle right here, like they could be showing you, we just know these two angles are congruent. So maybe this is like an 80-degree angle, and this is an 80-degree angle. So that would mean this is a 10-degree angle. So here, right, these two triangles are similar to each other, but look at this here. This triangle is going to be way bigger. It's going to keep going. Look, it's going to keep going. It's keep going here. Eventually, these two lines will converge here. So even though we have an angle that's congruent to another angle, right? Angles congruent to another angle. We have an angle here that's congruent to another angle, and we have a side that's congruent to itself. We don't have enough to prove congruency right here. Okay, this isn't an ASA correspondence, right? It's not an ASA correspondence because this is AAS and this is ASA. They got to be the same reasons for both of them here. Okay, here we could say ASA because one triangle is ASA and the other triangle is ASA, or it's HL because we have H and L corresponding parts. Corresponding parts are congruent. Here we don't have corresponding parts, right? Because ASA is different than AAS or SAA. All right, anyways, there's that one. Let's see if we can do a couple more here. Number 10 and number 18. Problems are tricky, right? You're just trying to push yourself, trying to get yourself as far as possible as you can in geometry, right? It's kind of the thing here. Your time is limited. That's the thing that's that's limited right here. So you got to claw your way, scratch and claw your way. You can do it here. All right, use the figure and given information below to tell what method, SSS, SAS, ASA, AS, or HL, right? The ones that we've been working with here can be used to prove triangle ABO is congruent to triangle CACO. Okay, so this diagram here is in 3 dimensions. When you see the diagrams in the book with color in them here, note there's no color here other than marking up angles and sides. So when the shapes themselves, like the polygons themselves, are drawn with white in the interior, that means they're planar figures. It means they're just on a flat surface. These are triangles on a flat surface. They're triangles on a flat surface, triangles on a flat surface, okay? Here we have a triangle and a triangle kind of meeting in space, right? We have multiple planes going on here. So plane AOB is different than plane AOC, okay? AOC, because BOC, they're non-collinear points. What I was going to say here, we're in space here, okay? So that's something to point out. So it's a little bit hard to tell, whether this is a right angle here or a right angle there, right? Because we're in space. So it's sort of crashing together. You're going to get better at viewing diagrams in space, especially when we do chapter 9, which is volume, right? Volume formulas and volume diagrams here. So anyways, so let's check this one out. Given AO is perpendicular to plane M. So if AO is perpendicular to plane M, and then any line going through point O in plane M is going to be perpendicular to line AO. So I know that BO, because it's in plane M, is perpendicular to line AO. Okay, so I draw this weird right angle thing. It looks weird because that triangle is kind of going like this. Right? It's kind of going like this here, and it's hitting, but it's basically going straight down into the table. Right, I have a table right here that I work on. This triangle is going straight down to the table, so it's erected kind of at straight up, right, straight up here. Okay, so there's AO's perpendicular to plane M. So we know that. And we know that OC, right? OC is in plane M, so that means it's perpendicular also through to line AO, and that's for the definition of a line perpendicular to a plane, right? Any line passing through the point of intersection with that line that's in the plane is perpendicular to that line. That's a definition that came up this chapter. So we know that those two things are true. BO and CO are congruent to one another. We know those things are true. So the question is, can you tell, can be used to, so in all these problems here, you're going to have problems 10, 11, 12, 13. So it looks like if I'm reading this correctly, right, and part of this is just you're developing your reading skills this year, practice reading math problems. Oops, I'm going up too high. In all these, the triangles are going to be congruent to one another, okay? So you just need to figure out what reason. So this isn't going to be they're not congruent, right? That was earlier. They're going to tell you if it's not congruent, if it's a potential that there's not congruent here, okay? So here, how am I going to be able to tell triangle ABO, which is this one here, ABO, is congruent to triangle ACO, which is right here? Well, here I have a side. Here I have a right angle, so we know they're right triangles. So the question is this going to be HL? Like, do we know that the two hypotenuses are congruent to one another? No, we know that another leg is congruent to itself here, okay? So from the reflexive, we get another side. And this is a leg. This isn't a hypotenuse here. So the thing that's going to get this one congruent, this triangle on the left here congruent to this triangle on the right, is a side, right? These two sides are congruent because they're the same thing. These two angles are congruent because they're both right angles. They both measure 90 degrees. And this OBO and OC are congruent because that's a given premise of this problem here. So through an SAS correspondence, the two triangles are congruent to one another. So my answer here is just going to be SAS. SAS. Simple as that. Nice and quick here, okay? So hopefully you look at these problems, try to solve the puzzle there in a minute or two, and you're not spending a lot of time on that one. Because again, I think you're going to have 3 proofs on this homework, okay? And the proofs should probably take you a good 15 minutes to do in total, okay? At least a minute or two to copy down the diagram and really think about it, and then hopefully like 2 or 3 minutes putting your ideas down. And if you don't get them on the homework, that's fine. We have the Jamboard the next day to kind of see if you can pick your way up through it, right? And get through it. And of course, you can come to office hours, come seek out help, other ways you have possible here, okay? So let's check out this one here. Again, write a 2-column proof. Again, I don't think about what I'm doing until I'm done copying down the diagram, writing the givens and proof statements. Because when copying down the diagram, I'm thinking about, oh, I got a bunch of triangles I got to deal with. So I'm maybe thinking about, like, I'm not trying to think about what I'm trying to prove. I'm thinking about maybe what I could prove just based on what's drawn here. I got some vertical angles going on. This looks like an isosceles triangle. What else we got here? We got angle 3, angle 4. They might come into play. It's possible those two lines are parallel to one another, right? I'm breaking down the puzzle as I'm drawing the diagram here. You're also given this given premises. As I'm writing them down, I'm like, cool, I'm being given angles are congruent to one another. One, for instance, is that angle 1 is congruent to angle 2. So I know that I have 2 angles of a triangle congruent to one another. That means I know that HE and HD will be congruent to one another. So I can mark that up, be like, okay, I might talk about that later. So I'm marking things up that I noticed as I'm thinking about tackling a proof like this. I also know that angle 3 and angle 2 are congruent to one another because those are given. That's also a given premise of this problem here. So all 3 of these are congruent here. So we have that. And then we also have that ES is congruent to DT. Whoa, and those are big lines. No. Whoa, ES. Yeah, ES is down here. Oh, this looks like a funky proof. Let's check this one out. Boom. And DT is here. So it's ugly when you're going through the actual diagram to mark that those specific segments are congruent to one another. But hey, we got it here. All right, and last step is to mark up what it is I'm trying to prove and put a question mark next to it. I'm trying to prove that angle 4 is congruent to angle 5. Okay, so if I can get a couple triangles where there are corresponding parts in, then if I prove they're congruent, then I can get the triangles congruent to one another. Okay, so this is how I'm going to start the problem. I'm just going to start writing, right? Mark it up, just start writing. Don't psych yourself out, okay? If you haven't noticed yet, I'm big at making sure you start the problem, right? Don't just say, oh, I don't know. I don't want to do this. This isn't for me. Well, a lot of things aren't for you, right? A lot of things in this world are not for you, but right, you got to push your brain to hopefully get some stuff that maybe you don't want to do, right? It's good for your brain and good for your growing and tackling problems that are difficult, right? That are difficult in the world here. But anyways, this isn't difficult, right? It might appear difficult, but it's luckily that a problem like this doesn't matter, right? We want you to practice on problems that don't matter first before you are leading us here in the world about a couple decades after I'm trying to lead you guys here. Anyways, we got my given premise here. Step 2, maybe we're thinking about what we're trying to prove. Trying to prove angle 4 is congruent to angle 5. We got that one here, and how are we going to do that? I know that. Okay, so I got HE is a side of, maybe I'll start marking up, and hopefully I'm right on this one here. Breaking down a puzzle. My guess is, looking at this one, that HE, because it's congruent, I'm just a little too thick here. Let me get rid of this. I'm thinking that HE, because it's congruent to HD, is going to be part of a triangle that's congruent here. So maybe let's find it. We got to get angle 4. HE is part of a triangle that includes angle 4. Angle 4 is one of the triangle's angles here. And this side, HE, is congruent to HD. So my guess is, yeah, I think I found it here. So here, you're like a doctor going in for surgery, trying to figure this out here. Let me change colors. What color haven't I used yet? I used green. I think let's just look at these triangles together and see if I found the right ones. Let's check it out here. Boom, boom. All right, check it out here. Whoa, there's a lot of information. Man, you're getting like really down into the weeds of diagrams and whatnot. So this is crazy. It's like, this is it. Like, why proofs exist is like really just getting used to diagrams, breaking down the puzzle. How are you at solving puzzles? Can we help you solve puzzles this year? Okay, so check it out here. HD is congruent to HE. Okay, so we have this side of the green triangle is congruent to that side of the blue triangle. We also have angle 3 is congruent to angle 1. That was a given premise. So this angle of the green triangle congruent to that angle of the blue triangle. Sorry, green triangle, the blue triangle right here. And finally, we have this side here, DT, is congruent to ES right here. ES right here. So it kind of looks like this green triangle here is the same. It is the same as that one. And the reason is what? SAS. Hopefully you see it there. But if I just slid this down, right? So like think about this. If I just like moved this down here, slid this down, boom, right? This side here would be on top of this side here, right? That side here, slid it down, that side here. This side here, slide it down, that side here. So that's how we're gonna get there. That's how we're gonna tackle this. We just need to organize our thoughts and put it forward and make sure we get it through here. Okay, so first step is, well, I got the angles. That's nice. Angle 1 congruent to angle 3. So we got 1 angles here. We got to get the sides that include that angle here. So given premise, DT congruent to ES. There we go. So we've already found a pair of sides. Oops, let me get a thinner pen here. Okay, we've already found a pair of sides. Okay, we've already found these guys here are a pair of angles. We just need to get those remaining sides here. And those remaining sides were just HD congruent to HE. And so here, right, there's so much information to keep track of, and you'll get better. That's why like you stumble. You don't get every proof that you get, that you do, right? Because you want to stumble, you want to get better from it, and eventually you get good at solving puzzles, which is really cool. I was never really that good at solving puzzles, that's for sure. But I'm getting better, right? Because I'm doing this for a few years now, which is kind of nice. Okay, so anyways, I want to get HE and HD congruent to one another. How did I get that? Well, I was told that angle 1 is congruent to angle 2, and those are 2 angles of a triangle. When you have 2 angles of a triangle congruent to one another, then the sides opposite that. So HE and HD, because that's opposite angle 1 here, are congruent to one another. Okay, and that is through the converse ITT. Converse isosceles triangle theorem. The converse of isosceles triangle theorem. Okay, start with the angles, it gets the sides congruent. Okay, step 3. So this is just a 4-step proof. This is a hard one. A lot of people are like, I didn't get this. I lost it. Turn in the homework. Oh, I didn't get the proofs. A lot of people say that when they turn in. Like, all right, you get it. But you took the diagram down. You thought about it. Didn't crack the code. That's what good old Mr. Ford and your teammates, right? And the class is for, right? You need the class. You need each other. You can't you're not going to figure it all out yourselves. I would not have gotten this problem right probably in high school. So anyways, keep pushing forward, right? Keep on trucking. You got this, okay? HD is congruent to HE. That was important because that completed our triangle, the one in blue here. Maybe I'll switch to blue so you see it in blue here. Triangle HES is congruent to, and HE corresponded with HD, right? HE and HD correspond. So I'm going to just do it in the correct correspondence here. Okay, HD. And then what else? ES corresponded with DT. So that means ES. And then perfect. We have a D there, DT. There we go. Triangle HES is congruent to triangle HDT. And reason for that is SAS, my friends. SAS. Yes, SAS, my friends. And there we go. We got it now. So angle 5 is the angle HTD in angle triangle HDT. And angle 4 is angle HSE in triangle HES. So they correspond. They're corresponding parts of congruent triangles. And when we have corresponding parts of congruent triangles, what do we know? They are indeed congruent to each other. And what is the reason for that we write on proofs? I kind of just said it. It's CPCTC. And we drop the pencil. We're done. Enjoy the rest of the problem set. Have a good Thursday. I'll see you Friday. Bye-bye now.